Okay, so this is going to be a video showing off a method I made in order to make on and off screen indicators in Unreal Engine. So the way I have it implemented here is that if I shoot this object with a projectile, it creates an indicator at its location, and no matter where I go in the world, the indicator will update to stay at the world position of that object. And if it ever goes off screen, it turns from a square into an arrow that points towards that object and also rotates in the direction. So for example, if it's in the top left corner, it'll be pointing in the top left corner, and you can see as it moves along, the angle changes as well. And the cool thing about this is you can have as many as you want on the screen at the same time. So for example, I have 3 on the screen, and they all update independently. And let's say I add more. They all stay on screen. If I go up the stairs, you can see that they all track perfectly. And if I turn to face them, they all lay into view. So this is done entirely in blueprints. I know from what I've searched on the Unreal Engine forums, a lot of people have done this through C++, but I haven't seen anybody do this in blueprints. In fact, I saw a couple of people saying that it wasn't possible. But I used a couple clever tricks that I thought of in order to do this. So yeah, I think it turned out pretty well. So let's get into the how it's done. And yeah, I feel like I should also mention that this works in any type of game. So here's some footage of it working in a third-person game. As long as your player has a viewport, which is basically every game, it should function just right. And I've also uploaded a copy of this to the Blueprint website. So if you want to copy it directly from there, you can do that. So if I turn on my visualizer node here, you can kind of see some of the math that's going on. So I'll just give you a brief overview of that before getting into the specifics. So we have our viewport in world space here. That's represented by these teal lines. We get the midpoint of our viewport, which is that white sphere. It's in the direct center of our viewport. And then we also know where this object is. So we have our viewport in world space, and we have the object in world space, and we can create a line between them. And then all we have to do is find the direction of that line. And that's this represented by the orange line. And we can take a step along that orange line. So from our midpoint along the orange line, this is one unit vector. And then we create a new point, which is the green point. And then we cast that green point back to our screen. So I have the white point and the green point. Now I have them both in screen space. And then we can calculate the rise and run values between them, so like the slope. And then from there, we can figure out where the maximum screen size should be with that slope. And then that's where we draw our indicator. So that's just a quick overview. I'll go into more specifics in just a second. So the way I create this widget in our world is through the first-person projectile node. So whenever the projectile hits something, we go into a do once node, so it only happens once per projectile. And then I have a sequence node. So we create that blueprint, the widget blueprint, which I called OSI for off-screen indicator. And then we set our first variable. So this is the only external variable needed for the blueprint. And it's basically just a reference to the object that we're hitting. So for example, this cube, we need to make sure that the widget we're creating has a reference to that cube. So if I go into my widget here, we have this thing called targeted component. And then I'll go ahead and add it to our viewport. And then I also just am simulating the physics on the cube so that it's easier to illustrate how the indicator updates. So as for the widget blueprint itself, so you can create a widget blueprint. I already have one created, but if you want to make a new one, you just select that. And then on the widget blueprint, you'll be in the designer page. What you have to do is add a canvas panel. And then this is an image. It's just an image. The important things to note here is that the anchor needs to be in the top left. So if you select this, the top left, and the alignment needs to be in 0.5, 0.5. As for the position, it can be anything because we're going to be updating this in real time. And then the size can also be anything because we do some adjustments to make sure any size works. So into the graph, the first thing we do is create a timer. You can use event tick if you want, but I'm just doing a timer so it doesn't update every frame. We don't need it every frame, but we do need it several times per second. So on event construct, I create a set timer by event. That event is called OSI timer for off-screen indicator. And then we go into a sequence node. So from the sequence node, what we have to do is find our clamp values for our icon. So we never want our icon to exceed the edges of our screen. So for example, if I set it to 0, 0, Let me set the position to 0, 0. You can see that it's overhanging the side of the screen by half of the sprite's dimensions. So the minimum position that we want this to be is at 50, 50, which since this is 100, it'll be half the sprite size. So we do some calculations here to figure that out. First, what we do is we need to do a check to see if the viewport is changed, because if the viewport changes, the clamp values we're going to be using also change. So if I do a print string node here, you should see that this event only triggers when the viewport size has changed. So for example, when the widget is created, it fires and says hello in the top left corner, but it never fires again, right? But if I full screen the game, our viewport size has changed, so then it prints hello. Also, if I change the screen at all, it'll also print hello. So anytime the viewport size is changed, then we need to update our saved viewport size variable. So here's the code. So first we check if it's equal. If not, then we update the saved viewport size to be equal to the current viewport size. And then from there, we go on to calculate our clamp values. So our clamp minimum will be, so this is a reference to our image, which I called indicator icon. We get it as a canvas slot. We get the size, we divide by 2, so the 100 becomes a 50 in our case. And we set that as our clamp minimum, which will be 50, 50 in our case. So for our max clamp, what we do is get our save viewport size and divide it by our viewport scale. And that'll make it so that it works in any resolution. It'll give us the bottom right corner in any resolution. So our top left corner is always going to be 0, 0. But depending on our player's resolution, like what screen they're using, the bottom right corner is going to be a different value. So what this does is just a calculation of what that value is going to be. And then from there, we subtract our clamp minimum and we set that as our clamp max. So that will give us the bottom right corner minus the size of the indicator icon. So it should be flush with the wall. So in our case here, it would be 870 and then 1030. So that's it for the first sequence pin. On the second sequence pin, what we do is we get that reference we made to our object. So this is the cube. The target component would be the cube. We'll get the world location and we set that as a variable called object location. And then we go into this node. So this is a custom function I made. It primarily uses a built-in Unreal node called project world to screen, but I also added a couple of extra checks to it. And the reason I make it a function is because we have to call it one more time in this blueprint. So instead of reposting the code, I just made it into a function. So we feed in our world position. So for the input node, we have world position. Outputs, we have, is it within the screen clamp, which is a Boolean. And we also have our widget screen location. I actually don't use this, but I leave it exposed just in case I want to use this node in the future and make some changes to it, because we actually set this variable within the blueprint. So from our world position, we take that, we put it directly into our project world to screen node with a get owning player for the player node. And I also have this as player viewport relative. I don't think that really matters. And then I also divide the result we get here by the viewport scale, and I set that as our widget screen location. So this node, the reason I have custom checks here, which I'll get into a second, is because this value that it returns, I'm pretty sure it's broken. So if I promote this, or if I print string this, so the way this is supposed to work is that if you're facing the object, it's supposed to print out true. So we're getting the world position of this cube and we're saying, hey, is this point on our viewport? And it is, right? So it's right in front of us. So it prints out true. And if we're facing away from it, it prints out false. So that works fine. The issue is that it seems to be a dead zone. So it's on our viewport. It's on our viewport. So now it's not on our viewport. The midpoint is not on our viewport, but it's still printing out true. And I think the reason for that is because we're technically still within 90 degrees or maybe 180 degrees of facing the cube. So it prints out true. Prints out true, true, true until we're facing all the way away from it into false. And within that dead zone, it seems to be giving me weird values. So that's why I add an extra check onto my function. So I have 3 branch nodes here. If any of these are false, it goes into the return node with the Boolean within screen clamp as false. If all of them are true, then it goes into the return node with this within screen clamp as true. So for these checks, first I use the built-in one, which I think is faulty, and that's the first one we do. And the second one, we're going to make sure that the screen location that we set right here is within our clamp values. So I do in range floats, and I have the widget location X and Y for both of them, and then I have the clamp min and clamp max for both of them. And those both go into branch nodes. So if any of these branches are false, it goes into the bottom return node with this is false. If all of them are true, then it goes in this top node. And yeah, if you want to simplify this even further, you can just use an AND node for all 3 of these booleans. So if it's true, we go into the top node, and if it's false, so you go into the false or the bottom node. So from there, that gives us our widget screen location. So that's the object location on the world screen. So now we know where to draw our object if it's on screen. So we can go, if it's true, we update the widget location. So this is a custom event I made. It just has one variable called ONSCREEN. This is used for the rotation, which we'll get into later in this video. I'm actually going to disconnect it for now. This is the rotation section. And then again, I just do a second check just for redundancy, just to make sure that our point is going to be within our screen clamp. If you don't want to do this, you don't have to. I think all the calculations should work out anyway, but I just do it just to make sure if a weird value gets through here that we know that our indicator will still be on screen no matter what. So from there, we just set our widget screen location after the check just to make sure that it's clamped between these 2 values. And then we set the position of our icon as a canvas slot to that widget screen location. So we use the set position node on that. So if you followed this far, let me disconnect this. You should have, when you shoot the object, it creates an indicator on screen. And it works whenever the object is on screen. But as soon as it goes off screen, you'll see that it gets stuck and doesn't calculate, it doesn't update. And for example, if I shoot this and it goes off our screen, you'll see that it's anchored in the top left, even though the cube just fell behind us. So then when I turn back around, it'll snap to the ground, the indicator. So that's what our next, the next section of this video is going to be about, is what we do when the indicator goes off screen. So that will be when this branch returns false. We know that the object is off screen. And what we do here is we use the reverse version of this node. So this gives us, this node is called project world to screen. This one's called deproject screen to world. So we have the screen position, but we want to find where that screen position is in the world. So we get our player controller as the player, and we get our save viewport size, divide it by 2, and that gives us our screen position. So this would be the midpoint of our screen. From there, we set it as our middle point. So if I show you on the visualizer, you can see that this is our middle point, the white point. From there, we need to calculate what the direction is between our middle point and the object location. So that would be from our middle point, which is in white, to the object location, which is inside this box. It's the center of the box. We want to find what this direction is. So we use the getUnitDirection vector node, and we set that as our object direction. So the next step is to get the middle point and then add the object direction. So what this does is it takes a step in the direction of the object location. And this accuracy location variable is just the number of steps to take. So I found that 2 steps seems to be a good point. So 1 step would be like this in the middle. 2 steps is where the green point is, 3 steps, 4 steps, and so on. So as long as the number of, as long as the green point is still on screen, it should work. But I found that 2, anything over 2 doesn't really seem to change anything. And anything under 1 leads to some serious inaccuracies. So I would leave it either somewhere between 1 and 2, maybe 3. So from there, we have our midpoint towards the object, which is that green point, and we're going to be using this for calculations. So now we want to see if our green point is within the screen clamp. So it should always return true unless our viewport is extremely tiny. So what we're doing now is just reusing that function we used earlier, is world location within screen clamp. So if I go in, this is just the exact same thing we used earlier. And since we're only taking one step in the direction of the object, it should always return true because it's pretty much on the dead center of our viewport. If I go back to it, you can see that our center of viewport here, green point is here. It should always be on our viewport. Even when we're facing this direction and it's invisible, it's still considered on our viewport. The node supports this, even if it's technically behind our viewport. But I can get this to print fail. So the way I would do that is if I go in game and make it really small. Well, let me create the widget first. That's my mistake. If I make the game really small, then our green point won't be on screen. If I bring it back, it says fail, point not on screen. But that's like a really niche scenario. It wouldn't really happen in game. So if this is true, if this check is true, then we can move on to what I would consider the most complex section, which is the linear algebra section. So I have notes here. What we do in general is find the distance from the indicator location in the middle of the screen. This distance needs to be multiplied until the indicator reaches one of the edges. So the top, bottom, left, right. It could also be in the corners. To do this, we find the run and rise values and then calculate the minimum required length of the line. And then we use the calculated values to find exactly where the indicator lies on the screen edge. So this is going to be a little bit difficult to explain, but hopefully all the nodes are easy to see on the video, so you can just copy them if you want. But I'll go through everything as best as I can. So we get our viewport size, we divide it by our viewport scale, and that we divide it again by 2. And this will give us the middle of our screen in 2D. So just as we did here, we got our the middle of our point in 3D space. Now we got to get it in 2D, which involves dividing by the viewport scale. And then we set our rise and run values. So we have the screen middle, and we have the widget screen location. And from there, we can just do a simple calculation of the distance between them. So we have this white point in world space, but we also have it in screen space. And we have this green point in world space, but we also have it in green space in world space. So we have a little point here, and we have a little point here, and we can just calculate the distance between those 2 points in screen space. And maybe I can just go over this again. So basically the way this works is that we have this orange line that runs directly to the object, and we want to emulate it and create this blue line. This is what we just did. And this blue line is along our viewport. It's parallel to our viewport. It's a straight line. But as you can see, so if I'm outside of our viewport, you can see that this orange line is 3D and this blue line is 2D along our viewport. But in game, they look the exact same. You can't tell a difference because they're matching up perfectly. So we take our screen middle 2D, we subtract the widget screen location, and that gives us the difference between the middle of our screen and the widget screen location. We set that as our rise and run values. And now this is a little bit complicated. So we take our screen middle 2D, we subtract our minimum clamp size, we divide it by our run and rise values, and this we take the absolute values, and this will give us the minimum length that it takes to get to one of the edges of the screen. So either the top left, or the top right, bottom, or left. And we want to get the minimum of these two values and set that as our line length. So I can explain this. So let's say we have our green point is directly left of our object. So we know that it's going to have a large run value. So let's say that's 2 steps. So it's going to be 2, 4, 6, 8, 10, 12, 13, something like that, right? But on the run value, you can see that it's very slightly going down. But so that would be like 1, 2, 3, 4, 5, probably hundreds of steps downward, right? So for example, if we take 15 steps to our left, it'll give us a point here. And then we need to take 15 steps down. And since it's only very slightly down, you'll be at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it'll give you this value here. So we set that value as our line length. And from there, we can multiply our line length with the run and rise values. And then we take our screen middle and we subtract this amount, which is the line distance. So we take our screen middle and subtract the line distance. And that'll give us our widget screen location. So that will give us the purple point. If I show you again, that'll give you, maybe you can't see it, but this purple point here, but in 2D space. So then we call our custom event again, which is called update widget location. And this I just have for my own personal use. This is the visualizer I've been using, but you can turn it off, or you don't need to copy it if you don't want it. So then from there, we just do the same check again. Again, this is redundant. You don't need to do it. We set the widget location and we set the position. So just the same as what we did before. So if you followed this far in the video, what you should have is an indicator that's on screen. You can see it, it tracks the object. And if it ever moves off screen, it still tracks the object no matter where your viewport is oriented. So the next step we're going to do is change this square into an arrow when it's off screen, and then update that arrow to make sure it points into the direction of the object. So just let me reconnect this node. So from our update widget location, we have the on-screen Boolean. So when this is called from here, we know that it's on screen, but when it's called from this selection, we know that it's not on screen. And from there, we put it into a branch node, and this is, we update the sprite angle. So if it's off screen, we want the arrow to point into the direction of the object. So what we do here is I have some very complicated calculations, but just as a brief overview of what this is doing, basically it's turning our screen from whatever resolution it is. So for example, most people will be playing on widescreen into a square, because we need a square so that when the point, I think I have everything connected. When the point is facing the top left corner, that it's at a 45-degree angle. If we leave the screen at a horizontal resolution, so like widescreen, this point would actually be pointing to the left, since it's more distance away from the middle of the screen than it is from the top of the screen. So it would be like, for example, it would be 500 points up, but it'd be like 700 points to the left. So that angle would be closer to 65 degrees instead of 45 degrees, pointing directly into the corner. So I do all this math just to make sure that our midpoint and our screen widget screen location are both treated as squares. So what we do next is find the look at rotation. So this would be the look at rotation from the middle of our screen, so in the dead center, to this object. We want to find the look at rotation as a square, if the screen was square, I should say. So we take the screen middle, we take the minimum value so that it's equal on the X and Y, and then we have our lerped values here, which we also put into the X and Y. And then we just add 90 degrees because for whatever reason it's offset by 90 degrees by default, or I guess minus 90. So we just add 90 so that when it's at the top of the screen, it's pointing up. And then we set our render transform angle on our indicator icon to that angle. And then from there, we need to update our indicator from the default square icon to the triangle. So the way I do this is I have two variables here that are both texture 2D. So this one's called pointing indicator, which is that image of the arrow that I have. It's just a simple arrow I made in a couple minutes in Photoshop. And we check if the current icon is equal to this indicator icon. So this node is really weird. I don't know why it's so big, but it should just be the get brush node. And if you expand it, it's really large for some reason, but it's the brush image is what we're using here. Oops. So we're just checking that the brush image is equal to the pointing indicator. If it is equal, then we don't need to update it since it's already the correct icon. But if it's not, then we set the indicator icon to the pointing indicator. So set brush from texture. So if the indicator is on screen, we want to make sure that it's a square. So I have another texture 2D variable here, and I have a image called OSI square, and I check just the same as we did earlier to see if they're equal. If it's true, then we don't need to do anything because that means on the last tick of the timer that it was also on screen, so it should be perfect. But if it wasn't, if it was an arrow on the last tick, then we need to make sure that the indicator icon is updated to the square, and we need to reset the transform angle back to 0. so that it's not tilted. If I didn't have this, you can see what would happen. The arrow would be tilted, and when this box is drawn back on screen, it would also be tilted. So we need to make sure that it gets reset. So yeah, if you followed this far in the video, you should have an indicator that gets drawn on screen. If it goes off screen, it draws an arrow that points directly in that direction. And it should be the full idea here. So if I can have as many as I want on screen, they all work perfectly. And I guess I'll quickly go over my visualization node if you want to figure out how to do that yourself. So these are just some nodes that help me debug this and visualize it instead of having to visualize it in my head. So the first thing I do is create a bunch of points from our viewport in the world space. So that's the teal line of our viewport that you saw earlier. And then I also take the widget location and draw that. So this would be the purple sphere that you saw. And I set those as variables. I draw a debug sphere at our object location. Then I create all the sidelines. I create a debug sphere at our middle point. I create a debug line that goes from our object to, or from our middle of our viewport to the object. I also create a purple sphere at our widget location. So that's the value I calculated here, I believe. Yes. And from there, I cast a point from the middle of our screen to the widget location. So that was the line that's parallel to the viewport. And then I also create a sphere at our midpoint adjusted towards the object. So that's the green point. So yeah, that should be everything for this indicator. If you guys have any ideas of how to improve this, I would love to know, because this is probably the most complicated thing I've made in Unreal so far. But it was definitely a good challenge to figure out. I thought constantly having to swap between screen space and world space, even though it's not ideal, it was kind of an interesting thought experiment. But hopefully Unreal or Epic figure out how to fix this node so that it works regardless of whether the object is on screen or not, because that would make it so much easier to do this if it was done entirely through one node. But yeah, if you guys know any other improvements that could be added to this, or if there's any other features that you think would be cool for this, yeah, you can let me know. So thanks for watching, and goodbye.